We have still 1 minute, so we can wait a bit.
Wow. We have two. Yeah. You're saying 1 year?
So I guess we can start. Yeah, hi everyone. Thanks for coming for my presentation. My name is Dmitry, and the title of my talk or discussion. I hope we can just have a discussion at the end for fun. Is keep calm and trust the AI. And I will start with an example, right? So imagine you want to do some kind of data processing, right? You want to analyze your financial statements or whatever. You want to buy a house, and you have a document with that, like some table or maybe a Word document, and there is this like a feeling that LLM is super useful here. I just want to put it into an LLM, and I want to say like, okay, do it for me. There's this feeling that I want to use it this way. But then there is a problem that everyone is aware of, right? So when you ask LLM for like a very basic arithmetic, not even talking about like complex data processing that involves complex mathematical expression, it just hallucinates some kind of a bullshit answer. Right? There's like millions of screenshots on the internet where you can make fun of this. And to add to that, it can be like extremely confident in their response. Even if you ask it like several times, are you sure? It's like, yeah, 100% sure. This is like super true. Right? So this is the problem that I'm having, that it feels useful, but it's also incapable of like basic arithmetic. So how do we escape that? Or can we even trust this essentially? Because like every day we see these examples that companies, they solve yet another mathematical breakthrough, whatever. They crack like unsolved problems, but can we really trust this? Or like, or better to ask, how do we trust this? Because imagine like, okay, we do this financial statements example, and this thing says like, okay, we are billionaires, fine. That's okay, sure, yeah, sure, 100%. We are a billionaire. So this we want to avoid, essentially, right? How do we start trusting this system? And maybe the way we start trusting the system is we can give ChatGPT or whatever LM we are using, Claude, we can just give a calculator, right? And just ask it to do something for us, an actual calculator, instead of relying purely on like text generation. And maybe many of you already know, there is actually a thing to do that. So this is this mysterious MCP that is everywhere, kind of maybe heard about it. It's called Model Context Protocol, and the way it's named is like super confusing because like it has nothing to do with context. It's like not a protocol. What is model? So the way it's better just to remember MCP and don't think about model context protocol. This is absolute nonsense in my opinion. But what it essentially does, it gives you a mechanism to connect your LLM with a tool that you want to expose, right? And also give some kind of features to like track progress, how this tool is being executed, like logging. You can ask or like you can ask users extra questions if you're unsure from your tool. But it's essentially this kind of a mechanism or a standard, if you'd like, to do that. And for the purpose of this talk, let's focus on tools specifically. And the easiest way, at least in my opinion, to start experimenting with FastMCP and adding tooling to your LLM is the FastMCP library in Python. And it implements all the features of MCP, and it actually just drives the standard forward. So they sit together like, okay, let's add this feature to FastMCP, and it's just in the standard of MCP. And the tooling in this library is like super simple. Just define a function that does something. You annotate it with like some documentation. You annotate the arguments. You add some tags, etc. And all of those descriptions, they basically act as prompts to LLM. And LLM will start understanding what it needs to do, given this tool. And you can experiment with that, right? So what I'm going to do now is we're basically going to connect LLM through FastMCP to RxInfer, right? And the reason for RxInfer, I mean, all of you know, of course, but we want it to be fast. We want to be a fast processing and want to do some kind of uncertainty estimates, right? And we'll do Bayesian reasoning, and it's a best toolbox. So everyone, thanks for helping, by the way. So this is how it looks like. Actually, I have a code repository. It's in reactive base. You can all experiment with that, see how it works. But I essentially have some kind of code in Julia that I implemented first in Pluto, and I just import. Super nice, super cool. So you can play with this repository both from Pluto or from MCP, and then I have like a set of simple functions from Python that calls the same functions from Julia, and I use Julia call, I think, for that. Yeah. Of course, there is some kind of latency delay for starting the service. Julia starts slow, blah blah blah, and it's actually a bit of a problem because so all these things that I'm going to use Claude, they assume that fast like MCP server starts instantaneously, so they just kill it if it doesn't start like in a certain time frame, and they say okay, error, and there is no easy way to control it. So I needed to kind of make it complex. So I have another MCP server that connects to my MCP server. There's a double layer just to start Julia first and then connect it to Claude. But basically, I want to show you what it is capable of, right? And I will try to do a little bit of demo. So we'll see how it works with demo. But imagine again, I have a data set of some kind of houses, which consists of different parameters like number of bedrooms, number of bathrooms, living area, floors, whatever, basement area, year, has a label, and also the price that the house has been sold, right? So, and I just want to analyze, okay, what is this data set is about? And maybe I want to do some predictions. I want to know, maybe I want to buy a house. I want to do some basic data processing on this data set. So let's try to do this. People online, can you still see my screen?
Yeah.
Yes, I can.
Because I changed the settings, so now I have like just a single screen, right? So we have a chat. Of course, I already experimented before. There was an old chat. I can show it as well. But basically, what I want to do, right? I have like this file. Maybe let's do the following. So, do you know about RxInfer? Can you use it as a tool? So yeah, it says like blah blah blah. Of course, I know. Okay, I have some connected RxInfer tools in my, and of course you can also check it here. I have RxInfer, etc. So it says yeah, I can do some kind of Bayesian inference with RxInfer, super cool. And say okay, I have this data set that loads. It's users loads houses CSV. Please provide it for me.
Yeah, you have a slash after Dmitry.
Okay. Sorry. Try again. You can access it. Just do it. Okay. Good. So yeah, there is always demo effect, let's say. But at least we from the talent to do this. Yeah, I mean, it's again probably has to do something with the fact that I have this double layering of LLM to access my local machine as well. Blah, blah. Okay, so it did some Bayesian analysis using an actual RxInfer, and it also was actually kind of fast. And what it says, okay, it worked, the model trained successfully. Let's try to describe the data. You can also see what kind of result it returns you in case you want to double check what it's actually doing. And the coolest part is that it actually generates you some kind of cool output out of that, which I didn't even ask for, right? So let's see what it is doing. So it gives us like the total number of houses in the data set, average price, price range, like number of features. We can see, yeah, what kind of values we have in our data set. And this is super cool. So we can start playing around with it even more. So, okay, I want to buy a house has 2 bedrooms, 1 bathroom, 2 floors, approx living area. It's 10 meters square, but I don't know build, and I also don't know label of the price. So now instead of like again hallucinating the answer is completely unreasonable, maybe this data set is local to Eindhoven, for example, right? Or maybe it's local to my specific region. And basically, yeah, it called the function, it returned some result, it provided the arguments that I actually just gave in a natural language. It composed the request, it gave some result to me. So because I set it up the function to give me also standard deviation in the mean. And also it gives some output, but I don't like the textual output. I'll say, okay, visualize it Gaussian distribution. Or yeah, that one. Maybe yeah, I don't know what this Gaussian distribution is, but the point is that I want some kind of visualization of it. Yes?
Who built the model? Like
I built the model. Yeah, I built the model.
previously.
Yes. Yeah, so 95% interval says that according to my model, the house can be for free. So we have a pretty huge standard deviation here. This also says that, yeah, the model is uncertain. So the model now cannot say that there's a 100% sure guarantee that this house will narrow the uncertainty. Okay. You see what it did? It basically injected the prompt for me. It's a good one. So let's see. Okay, so it actually injected
Huge difference.
this 1990 year, and the label is a huge difference. Like wow, so big. So now we have a better estimate. Let's see. So previous unknown and all features known. Let's wait a bit.
Is it plotting these things with an MCP as well?
No, it's some kind of Claude feature. So Claude implemented this.
So this is a mid-journey.
This is
Like a vision GPT.
I think it's inside of Claude.
I
So
imagine
they
they have their own plotting.
yeah, they have their plotting MCP program, but I did not code the visualization specifically. Okay, and what we can play around it. Let's say, okay, I actually called the like agency, whatever. The house is from 2001, and the label is actually for estimate the price again.
While it's doing that, can you clarify briefly what the RxInfer model fitting?
Okay, so the model of RxInfer takes all the columns from dataset, and the price is basically the target. And it tries to build a non-linear regression model from those parameters into the price, and the parameters are being estimated with uncertainty, right? And I assume Gaussian everywhere. This is why you can go minus the price. But the idea here is that for the parameter or for the observations that you don't know about, you put an average from the data set, and you also put a very huge covariance on it. So it basically tries to nullify or at least open the variance on those parameters.
You put all that information into the MCP of the coupling.
Sorry?
You put all the information that if you have no data about something, you have to put in large research.
Yeah, so the function handles that. The function that I coded in Python, it takes this into account. Yeah, so it checks what kind of an argument LLM provided, and if, for example, some of the column is not present, for example, the year that the house is built in, it's missing. It basically puts an average there, an average year built, and it puts a huge variance on this.
So that's information that you put in.
Yeah. And then we can play around with that. And I think, yeah, do you have more questions about that?
How do you hook up a specific RxInfer model to that?
So I pre-built this model specifically for this example. Yeah.
How do you hook it up? Is it also just with a Python call?
Yes. Maybe I can show it again. So basically, I have this file RxInfer.jl where I define my models. And then I wrote a function .run analysis that loads this model, provides all the data, does some kind of pre-processing on the data, checks if some observations are missing or not missing. Yeah, you can also control the EMP iterations, etc. And then it provides the result as results.posterior dictionary.
A run analysis is a Julia function.
Yes, it's a Julia function. Yeah.
Yeah, you call it.
Have you experimented with having Claude write the model itself as an MCP and serving that or not?
No, I have not. But I think that might be a logical next step. Yeah. The idea here that I will kind of also talk a little bit about here is that maybe going a little bit forward till the end of the presentation, you can trust LLM as long as you trust your tools. So I, for example, trust the tool that I wrote, right? I trust this model for this specific example works. But if you let LLM write your own tools, then there's a question kind of shifting. Can you trust the output of this? But this is a bit at the end of the discussion. Okay, let me continue. And then I just had this more examples of how I just played around with that. Again, can you run some Bayesian analysis on my data set? It runs some function. It generates this beautiful plots, which are amazing, actually. And you can even ask it to change the color, because I don't like the color, just make it green. So, and again, yeah, this is probably some kind of built-in MCP server. You can prompt all kind of questions as long as your tooling supports, as long as the MCP server supports the way you would want it to do the processing, it works really great. You can also like compare estimates, right? You can ask some kind of questions, and it generates this super nice plot for you. I really played a lot with that. Yeah.
So the active image question here, can you ask it, what do I need to know about the house in order to reduce my uncertainty?
I think you can.
Yeah, can it calculate entropies, reach information?
No, my tool cannot do this. No. But I mean, you can design a tool for this specific purpose.
I think your tool can do it, actually, if you will ask it very well, because you can compute standard variances, right, with different features and find me what features I need to find out to reduce my uncertainty. What is the cheapest way? And you can put some form of a price. It will try it 5 times. It will find standard variances, and it will say you that the active inference way, you need to find this feature first.
Sir Nicola, can you repeat the last sentence?
Because your tool provides you for each subset of features standard deviation or variance, it can just try many kind of like artificial examples to find out what is the best way to reduce variance.
Yeah, for example, yeah, it can try to remove some of the observations and see what is the most influential parameter.
Yeah, but I think so. My question is more about, so if you ask it naively, it will probably use some form of descriptive statistics to make that decision.
Mm-hmm.
But if it knows that outcome of the stereo distribution and it knows about things like active inference and Bayesian optimization, could it use that stereo distribution to generate an entropy?
I think you can design a tool. For example, there might be an extra function in the MCP server that computes the entropy given the result, and you can put a description of this tool is that run this function every time you have the result, and in the description of the server you say like, okay, in order to do proper Bayesian analysis, you need to do this kind of steps. So I think you can do this.
Turn Claude into our own active
Yeah.
with the skill set.
It's also that the AIs always ask follow-up questions, and now you can make it ask useful.
Yeah. Alex?
You were saying you can ask it to do anything that your tooling supports, but if you hold out one of your supported functionalities, but then ask it to do that, is it going to give you an error saying I don't have proper tooling to do that, or is it going to try to hallucinate and you're not going to be able to tell which is really truly supported functionality and which is?
That's a good question. I haven't tried it, but my guess would be, so every time it uses the tool, it basically shows you that I used this specific tool. And if it doesn't show you, you can think that it didn't do anything and it's kind of hallucinated its way through a text.
Yeah.
So you can also
you really want to understand your tooling well then.
Yeah. Yes. Or you need to trust your tooling really well. Like you need. There is a question online.
Yes, thank you for the presentation. I really like it. Nice job. I have a question. How hard is it to set up? If I want to start using this to make everything up and running?
FastMCP is super easy to set up, like extremely easy. But there is a repository. I will also link it at the end on GitHub Reactive Base, RxInfer MCP example. So you can just check it out and try to write a README with Claude to set it up. To set up it with Claude, you need to pay. But you can try to set up with like Claude, for Claude Code, you also need to pay. Back then I set it up with Cursor. It was also easy. So basically there are just some MCP settings you need to provide, like a link to your MCP server, and then it just works.
Okay, and this one that you're running, it runs outside the subscription model, is the one that you actually load by calls with the API.
What do you mean?
Like for example, you have the Claude subscription that you can actually run with VS Code, but additionally, there's separate things that you need the API and not the subscription. So which one are you using? The API that individually you have to buy credits?
I use the subscription.
Oh, nice.
Because MCP server runs locally on my computer right now.
Okay.
It's just that you need to pay for it because the setting to set up MCP server is paywalled.
Of course.
Lock the settings unless you pay. Okay.
Thank you.
Nicola has a question.
Have you heard about startup called Manus?
I heard about it, but I don't.
But because they sell in exactly what you showed here.
Okay. So I give it to you for free.
Nicola, is it using RxInfer months?
No, they use an R, not RxInfer, but I mean they also, but for end user, it doesn't matter really how this normal variance plot are built, to be honest. And it does not matter how because you see LLM also kind of, once you have this tool, it still stays a black box that just generates you final result. And if you will go back into the chat and ask how certain user's result is good, it will say, oh, it's perfect result. I will never make mistake. So to be honest, I'm quite skeptical about Dmitry's argument that tooling make LLMs better. They still super confident in whatever they're doing. and there is no way to figure it out that they actually certain in what they did. But returning back to the question, no, Manus is not using the RxInfer, they're using R, but just R language for that. But it's.
But Mikola, in a sense, you're right, but then you are in control of the models that you select. So then you can inspect your assumptions. At the end, it's running the model that you built. You actually learn it, of course, for an end user that has no knowledge. There's a difficulty, but for you that you can build your own models, then you can trust what you did a little bit.
Yeah, but if I build my own models, I don't need AI, right? So to build, I don't need Claude to build me this plot.
Yes,
I will counter argument that at the end of the presentation.
Yeah, and one short, and you start, I was just a bit annoyed that you started your presentation that LLMs cannot do mathematics, but your first slide is radically obsolete. If you will open the Claude chat right now and ask you to subtract two numbers, it will do it correctly.
Yeah, because it uses Python under the hood.
No, it's not using
Python
Python.
tooling.
Actually, at first, they used tool call, but right now it's doing arithmetics, basic arithmetics by hand correctly.
Okay, can you trust this?
No, but I also cannot trust these plots outside of the RxInfer generated.
Okay, so okay, it's good. We heard you. Fons had the question.
Yeah, I also heard that Julia, the Julia company, that they made Diet, which is a new language for simulating physical systems. And now their whole focus is to, because they have a contract with Anthropic, to build it into Claude so that when you ask things like, if I shoot a rocket 2 meters high, blah, 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 that it can calculate with physics. And the point that they have is that if you give an AI access to a like strongly typed language that can do these things, then it's much better because it can do it in a loop.
Yeah.
So it seems like a promising idea
Yeah.
to make it write a model because you give a lot of error messages and then it will write.
Yeah, I think that as well. Yeah, and again, this is just to demonstrate what it's capable of, right? It's like, of course, a very simple model, a very simple data set, very simple processing, etc. But even this is already super cool, and you can try to expand that and add more tools. So now I can ask this kind of a simple question, and then with this simple tooling, we can make more or a better estimate. We can get some kind of uncertain estimate, and yeah, basically, why stop there, right? So let's connect it with RxInfer, with PyTorch, Pandas for data processing. Let's instruct LLM how to do all these mundane tasks that you need to do, like normalize data set, like impute it with or replace categoricals, whatever.
Yeah, well, we trained hundreds of thousands of data scientists to do in the last 20 years.
and then you ask, test all parameters for me. Oh my God, just test this all hybrid parameters in PyTorch. Try to think out what is best. Compare with RxInfer, do cross-check, check with the state of the art, etc., and you just go sleep or like enjoy your life. And then let's make it even further, right? Like connect it to our documents, to our notes, like skills.
From password manager.
Yeah.
Password manager.
Emails, whatever.
You're building open call.
Yes, I think this is what Claude is doing essentially, or like open code, open. So this is, in a sense, this is not new. It is already people already did a lot of tools for you, and it also works not just specifically for ChatGPT. It's sort of like already accepted standard. So Claude, ChatGPT, Gemini can work with that. And I also heard an argument that this is kind of privacy breach, but I actually think it's the opposite of that, because in my view, LLM doesn't even look at data anymore. It only tries to figure out what kind of tool to call, and where to pass it. And as long as you trust the end tool, like data processing tool, your data actually is not even leaving your environment. It's like still on your Google invokes a counter with this.
Well, I would say, which is exactly the problem with OpenClaw, is that if I write a tool and I masquerade it as being a calculator, and I registered it as an MCP, and I can convince some of these companies to pass this data on to me, and I'm a security leak, right? I can get all this data.
Potentially, yeah.
So now the cat and mouse game is no longer about social hacking, social engineering to convince old people by phone to give me their bank account. Now I have to convince the AI that I'm in dire need of this bank account.
Okay, it might create a different route to data flow, okay. One more thing. So this is maybe a counter argument to Mikola. Right? So Mikola said that if I write my own models, I don't need AI for that. So my argument, and maybe we can discuss it a little bit after the presentation, is that LLM is not an AI, but it's a UI. It's the best UI ever created. Because if you think about it a little bit, so what I did with the dataset, I was perfectly capable of doing it by hand, right? But if you look at this modern UIs, it's just complete nonsense. Like this is the gazillions of buttons that you never ever use. Have you ever seen that this dock has this paste button? Have you ever used this button? It's like it's ridiculous.
You've never used a format painter?
And then, okay, I have this data set. Okay, I can just click some buttons, whatever, and do the analysis that I actually wanted to do, right? But instead, I just have now just one button, right? The LLM is essentially reduced UI to a single button. It's like so cool. And I just tell it, okay, I want to do this. This is nice. I don't need any other button. I don't need the paste button. I don't need formatting button. If I want to change the color, I use the same button.
And the efficiency comparison between clicking paste and saying paste.
Depends on how good of a prompt engineer you are.
Not even the top if you say change my font to green, how much are we?
Yeah, I think it's less efficient. Definitely, like typing is less efficient. But the thing is that if I never ever need this button at all to change the color, it's just useless. If I never ever need it. But
I mean data center efficiency, not like how many calories you're burning typing make my plot green. Sorry.
Okay, the current state is extremely inefficient.
This is a great idea. So instead of a standing desk, you have this like 9 scoreboards there. So you're generating electricity for those prompts that you.
Now you have to earn it. Those calories just go back.
So in terms of like thinking, what does it take to produce the result? Yeah, it's extremely inefficient currently. But hopefully it will become more efficient because there's clearly very useful. It's very useful, and I honestly think that this is the future of user interfaces, where we don't have these buttons anymore. We just ask it to do things, and then.
I completely agree. I think the washing machines will have an LLM interface.
I want to wash.
Start in 3 hours.
What if you want to wash like a very specific sweater for 2 hours and 20 minutes? Do you know how to do it on your washing machine?
I was thinking about washing machine apart from the fixed it before. I think I do. My wife wants.
Regarding the efficiency of prompting, if we're asking the LLM to become just a UI for tool selection,
yes,
do we train the LLM differently, more narrowly, and perhaps much smaller to be able to just do tool selection with basic user interface and the full general AGI versions we have now?
It's a good one. I honestly don't have any experience with training, so I don't know.
The current new set of LLMs have been trained more in that direction, right? I mean, the first level of training you do for next open calculation is the same, but the supervised fine tuning at the end is substantially different and allows you to have just much smaller models because they don't need to have world knowledge, they just need to have tool knowledge. So it's quite a lot cheaper.
Yeah, but Dmitry, I have a question about this weather example, because the problems that I have with LLMs is not that they cannot call tools. It's the problem, yes, I don't know how to do this very specific operation on my washing machine. LLMs also does not know, and it will just do something telling me, oh yes, it's a perfect way to do it. Press some buttons and my sweater will be destroyed. So the problem with LLMs is not that they are not capable to do stuff. It's that they don't know the boundaries of their capabilities. I can certainly say that I don't know how to do this stuff in my washing machine. But LLM also doesn't know, and it will certainly say that it knows how.
That could be the true. Yeah, maybe when
Solved by tools, right? Like for example, Cloud saying, yes, I can totally write that script, but nowadays it will run the script, see that it doesn't work, and tell you that it couldn't write the script.
Okay. So you're suggesting connect Claude to operating system of my washing machine?
End of use.
Yeah, Mikola, you only get a limited number of tokens when you're online.
No, I mean, Mikola has an opinion that is valid. I think to connect what Alex said, if we train it with different tooling in mind, it might improve. Or might be not. Yeah, we'll see. Maxwell, you had other question? Or? Okay, sorry.
And it's important for the tool to be really specific, right? That it can take data that it can work with and reject other data.
Yes. Yeah. And you need to trust this tool, right? Otherwise, yeah, it defies the entire purpose. Yes?
It's kind of follow up on this. That still, it's like these models do kind of lead to a lot of cognitive offloading onto them. And I guess kind of as a response to the previous statement about like, oh, you can't trust them. No, you can't. You have to remember that you can't, right? And that you have to verify it. Yeah. It's like, if it tells you it can, ask it why. Read that, see if it makes sense.
I think if I need to verify it, my cognitive ability needs to go to verification, right? So I don't see how it's kind of resolving the automation paradox. So if I right now need to verify all actions of LLM, did I really did an automation or I just switch my work? So
I think you remove a lot of tasks that just mundane kind of. So you may want to ask a LLM to do a linear regression. And there is nothing to verify really. Like there's a very simple process of doing linear regression, right? There's a very basic operation, and then it just gives you the output. So again, in principle, you can click through 10 buttons in Excel sheet and do that, or you can just ask LM to do that very fast. And I think it removes this friction.
To follow up on that and to respond to this, it's kind of like, yeah, if you did the linear regression in that case and you didn't know about your Gauss-Markov assumptions, then you don't know that your linear regression works or not. Yeah. And here's the same case where it's still up to you to know your assumptions to make sure it makes sense. Yeah. Just simplifying the interface.
Yeah. Mikola, you have more or?
No, I have only counter argument to myself because in your slide.
Okay.
Because in your slides you make very good example, because I think where we need to go is like automating the verification tool set, and is a great example that you made in your second slide when LLM proved some theorems, but there people that doing it, they're actually smart. What they're doing is they write their hypothesis in Lean, there is specific mathematical language, and then because hypothesis written by human, if it will be proven, it's correct. And then they say LLM, oh, generate a lot of tokens until you will come up with the proof. And one proof is done, you can run the compiler and check that is it really correct. So I don't need to do any verification. Verification is done by Lean. So only thing that I need to do is to write the hypothesis by my hand. So I don't need to do a proof. I need only to write a theorem which I would like to prove, and AI will figure out is it correct or not. And here I see a clear automation because I don't spend, But mathematics is very good because it's like all logical steps, and real world, I don't see how to verify real world. So only if I have a perfect simulator, but
I think to add to your argument, the LLMs are also very good in interpreting your request, right? So if you want this lean model or whatever, you can just write it in a natural language. It doesn't even matter if you use commas or not use commas, if your English is bad or not good. So in principle, again, I could just call this function myself, but I would need to form like a JSON. I would need to form like it's a specific format, specific column names, etc. And if I make a typo, it will just throw me an error. But LLM removes this entirely. Just does it for me. I don't need to do it anymore. Wouter, you had something to say.
Well, it struck me that so apparently Julia Hub is making Diet, and Anthropic is paying for Diet. So there will be a marketplace of trusted tools because Anthropic's trust and their value depends on how much they can trust their dependencies, their tools. Do you see a sort of a fight over who gets to own which tools? Like OpenAI is going to claim one particular tool, and Anthropic is going to claim another tool.
It might be. I don't know. It very well might be.
So then RxInfer could be very valuable.
Yeah. In fact, there's actually this Anthropic bot BAN, I think, as a tool, and ChatGPT bot UV, or the other way around.
Yeah, I think OpenAI bought BAN.
No, it's Anthropic bot BAN.
Anthropic bot BAN and OpenAI bot UV. So they are already actually competing for tools. Yeah.
Why did they buy those tools?
I think BAN is for JavaScript, right? So maybe because they want to draw this dashboards kind of and compile them with BAN. And OpenAI, I guess, because they want to run Python code. I don't know. Yeah, they have quadrillions of imaginary money. They can do whatever they want.
What companies do I buy?
There's uncertainty on the market.
Who would they buy RxInfer from?
From us.
From me.
Of course, I cannot sell it.
Can we make it closer?
RxInfer is for everyone.
Well, then just replace it with something that's private.
I will happy.
Yeah.
Okay. And if they make it better in the process, I would just join their team as well. We will join their team. Okay, that was my presentation. If you have more questions, discussions.
Use it for teaching RxInfer.
I think yes, and also Wouter has started experimenting with this kind of skills, right? For like how ReactiveMP works, and then LLM also goes tooling to go to a repository to read files, to compose all of this and to give it like a description how it works. We can use it for teaching, but also maybe indeed have like a predefined set of examples where students can play with sort of the same. And then show them what it is capable of, what kind of, it's actually a super cool idea, and see how they prompted, like what kind of questions they.
Yeah, there are some courses at TUE that are graded on that codes.
Yeah, there's a few courses.
These were just my experiments, right? How I prompted it, and this top bottom actually the LLM prompted itself. So what it says, like, okay, this actually would be interesting to see what will happen if we do this. And it didn't even ask for it, but I could imagine a student asks some kind of a question that is not here, and we see how they try to interact with this model.
Sorry, Dmitry, do we have some time? Can we try this active inference example from Wouter just in chat? Maybe it is.
Let's try. So what do you want to ask?
Please figure out the variables that's the most important to figure out to reduce uncertainty of my prediction.
We don't see your screen.
Oh, sorry.
Yeah, we have 5 minutes.
I have 5 minutes. Okay. So the most influential, I will not want to fix it in this data set. Just to support my point that it doesn't even matter if you just speak English. Okay. By varying each feature across its full range while holding everything else at the mean and measuring how much it's... Yeah? Boring?
That's why it's doing it.
I'll see. So, but RxInfer is super fast, so it should...
Is there something better I can do given tools?
No,
Leave out variables, was that the idea?
Well, you could so it's linear. Well, okay, maybe it's not linear, but if it's linear, then you have one coefficient for every feature. So you could break down entropy.
Yeah, but it cannot compute entropy, right?
Well, if it's a tool, right? If RxInfer passes posterior distribution back to Claude, essentially that's the question. Can Claude figure out that it needs to use that knowledge?
RxInfer is a bottleneck. You see, token generation is super fast, but RxInfer...
It's like super fast. So it was 1 minute.
On Sonnet even, not even on Opus.
Most influential living area. Least influential bedrooms. When you buy a house, Mikola, check living area.
Location.
But I mean, this is a fake data set, by the way. You don't have to base your... Don't take it seriously, right?
I'm glad I don't have to take care of my bathroom anymore.
Because yeah.
Can you scroll it down because it makes sensitivity analysis just to be okay. So what is it's writing? Okay. Just explain. Yeah.
Well, actually, because it's not linear, I know that the most influential is actually labeled because it's quadratic in label. So, but maybe it has a small constant.
Is your model quadratic in label?
Yes. So the price is quadratic in the label.
I know why I did mistake because it did not tell it not to make mistakes.
This is for next time. Okay, thanks everyone.
Thank you.
Thanks also for my...
It was great. Thanks. Bye.